So the next example we're going to look at is going to be example 4.2. This is found on page 78 in your textbook. I have the steps listed here, the overall steps, but it's really going to be a very similar process that we did last time, but it's just a different mechanism, okay? So first of all, we're going to draw the kinematic diagram in its closed position, or as we see it here, I'm going to call it the home position, and we're going to calculate the mobility. Then we're going to rotate one of the links so that it opens up the snips, which we're going to see in just a little bit, 15 degrees. And then we're going to move all of the other links and we're going to measure how far the handle had to go. Okay. So I'm going to go back underneath and we'll see the full problem statement here on page 78, for example, 4.2. And then we're going to see the SNPs, the compound lever SNPs that we have. So the problem statement says we're going to use this compound lever SNPs. This is like tin SNPs, okay? So if you have any of those at home in the garage and you need to cut something, usually that's metal, not super thick metal, but thinnish metal, you would use a pair of SNPs similar to these. And it says here that we're going to be using the handle, the top handle, as the frame. So when we look at the top of the handle here, the configuration, and it's going to make more sense when you look in your book, the handle starts here and it goes down and it's all one piece to the bottom jaw of that SNPs. Do you see that? Okay, so this is all the frame. This is all going to stay in the same place. Okay. And then we want to find out, we want to move the jaw, the top jaw, 15 degrees so that it's 15 degrees open. So this top jaw right here, we want to rotate about point A so that it's 15 degrees open, okay? So once it's open, we then want to measure how far did this lower handle move open, okay? All right. So first thing we need to do is draw the kinematic diagram and label it so that it accurately represents what we have here, okay? Now, the book already did this for us, so I'm not going to ignore that that's there, all right? So we're just going to peek ahead, okay? And you're going to notice that here is the kinematic diagram in position. So I want to kind of talk you through the labels that they did, because I'm going to use the very same labels, and I'm going to expect you to do the same thing so that you can kind of line things up here. So notice that we have frame member here at A. There's a connection for link number 2. And then there's also a connection to the frame at D. And this is going to be link number 4. Okay. So if we go back to the tin SNPs, okay, I'm going to zoom in here so you can see my labels. A is this pin right here. Okay. D is 2.3 directly to the left. I don't see many people looking up here, so gosh, I hope you get it. I know a lot of people say this is the step where they need some practice. So I know you want to get it done for the night, but this is 2.3 over in line. This is point D. So these two are our frame members, okay? Then what you're going to notice is I'm going to start back at A. We have this triangle right here, and it connects back to B. So it's from A to B, and then there's a special interest point X, okay? So if we look to locate point B, okay, to locate point B is 1.6 over to the left of D, and it's 1.2 down. Do you see that? Okay, so that's where B is going to be. B then is the endpoint of that link number 2. It's going to connect to A, okay? It's this top handle, all right? It's going to connect to A. And then what they did was they showed it going just straight out. Now, this diagram doesn't give us a length dimension. You just got to kind of put it out there. I don't know why they didn't. They gave us the other dimensions, but they didn't give us that. So you're going to draw it kind of a random length out to the right, and then you're going to connect it back to B, okay? So this triangle right here, link number 2, is representing that top jaw, but then connected back to point B down here through A. Does that make sense? So it rotates about A and is connected at B. All right. Now, let's look at link number 4. Link number 4 is at D.
Quick question.
Yes.
Now, part according to this drawing, D and A are on the same
Mhm.
Y plane, I should say. But according to the drawing, shouldn't they be about 1.5 inches difference?
1.5,
I mean, 1.2, fine.
1.2. No, no.
A,
A and D are in line. B
Oh,
is
right.
1.2 down. Yep, that's down there. Okay, B is down here. That's so A and D are in line. Okay.
all right, thank you.
Okay, so now we know where B is. Okay. Straight up is C. Okay, from B. And we can see that by adding 1.2 and 1.5, or a total distance of 2.7, is the length of link CB here. Does that make sense? Okay, straight up, vertically. And that C then is going to be also connected to this lower lever that's also connected to D. Okay, so if we look at that lower level, a lower handle, maybe is a better name. So it goes from D to C, and then the bottom would be this Y. Again, they didn't give us the distance out to Y, so we're kind of just showing it so it's down here like this. Do you see that? Okay. Random. I'm sorry. I hate that it does that, but it did. And then this link is straight up. So what I want you to do is go ahead in AutoCAD and create this diagram right here using the dimensions from the illustration and then the symbology here. So we're going to, and then the same call outs for each one of the links and the joints. I'm going to just pause our recording here. Okay, so now what we're ready to do is to move into new position link number 2. Now, as the problem statement said, we want to rotate this link so that it rotates about its fixed center of point A, 15 degrees counterclockwise or 15 degrees open. So we're going to use the rotate command. We're going to select the 3 lines that make up link number 2, and we're going to hit enter. Okay. Specifying the base position. This is the base of the rotation. So that's going to be the center of A. Okay. Now, notice that I'm not clicking yet. I can rotate this, but down on my command line, I need to leave a copy. Okay. So I want to put C and then enter. So now it's leaving that original copy behind. And now it's asking me for my rotation angle. I'm rotating it counterclockwise 15 degrees. So it's just a positive 15 degrees. Okay. So now you have this in its new location. We want to select each one of these lines. Just simply left click each one of the new position. And we're now going to put it on the object 2 layer. Okay. So you should have it looking like this. And then on our notes layer, we're going to add the dimension of 15 degrees. Okay. I know mine has 4 decimal places. We'll look at that in a bit. Yours probably doesn't. You can leave it at 15. It's totally fine. All right. So now we have that in position. The only other thing we need to do is we need to relabel the endpoint here as X prime. So I'm going to copy X. And then we're going to rename that X prime because that's the new position of that endpoint. And then down here, B is going to be B prime at the bottom end of that link. So I'm going to copy again B. And this is going to be B prime. Okay, it's the new position of B. Okay. And then A remains in the same place because it's fixed. It doesn't move. All right, so now what we want to do is we want to determine the new position of C prime, okay? Now C prime is going to rotate on the path that has the fixed center of D. So we're going to go back to our 0 layer. We're going to do a circle center radius. And at the center of D, we are going to put the radius of C. So you can go right to the endpoint of C. We don't have this. We didn't enter this endpoint. We went over and up with the dimension C. So we can go right there And along that path is where C is going to rotate, or C prime is going to rotate. Now, to find its intersection, we are now going to put in another circle center radius with the center position of B prime, and it's going to be the length of link number 3. If we go back underneath, link number 3 goes from C to B. And if we take 1.2 and add 1.5, that length of that link is 2.7. So back over here, we're going to do another circle center radius, center of B prime, and we're going to have 2.7 as my radius. So now the intersection of these two circles is going to be C prime, okay? So I am going to go back to my object 2 line. I'm going to connect B prime to the new C prime and then back to D. Those are the new positions of those lines. And 3 is really not in a good spot here. So I'm going to move C or 3. Put it right there, maybe. Okay. And then my new C prime is going to be from here to here. And then I'm going to double click and it's C prime. Okay. So the construction of C prime was on the center of D out to C. Okay. And then the intersection with the center of B prime and a radius of 2.7. Okay. That's the new position of C prime. And then what we need to do is we need to then add in the rest of link number 4. So I am simply going to erase those 2 radiuses that we just had. I don't need them. And how I'm going to get this into position is I am going to measure the angle from C to C prime. And then that's going to be the angle that the rest of the elements on link number 4 are going to move as well, about D. So I am going to go to the Annotate tab. And then we're going to go down to Dimensions. But to the right, there's this down arrow. This is the Dimension Style dialog box. Okay. And now what we're going to do is we're going to modify the current style. We want to go to Primary Units tab and down to Angular Dimensions, down and to the right. You're going to switch this precision from 0 to 4. Okay, 4 decimal places on the angle dimensions. You're going to hit OK, set current, and close. We're going to go back to our home menu, change our layer to notes. And now we're going to create an angle dimension, okay? Angle dimension from line CD to line C prime D. And this angle is going to be 34.3633 degrees. I didn't want it to like no decimals because then it's not going to be accurate enough when we do the rotation, okay? So now what we're going to do is we're going to rotate the other 2 lines on that link. So we already rotated CD. We want to rotate copy. So we're going to hit the rotate command, the line from C to Y and from Y back to D. Okay. Hit enter. The base position is going to be the center of D. And then now we need to hit C for leaving a copy behind. And then we're going to rotate this 34.3633 degrees. Okay. Enter. So put in all 4 decimal places. And now you're going to see it rotate down. And then I'm going to select those 2 lines and we're going to put them on the object 2 layer. Okay. So there's its new position. And then Y prime is going to be down at the end. I think it's there. Okay. Any questions at the moment? Alex? The dimension thing again? Sure. you have to go to annotate tab, dimensions, but to the right, there's a down arrow. And that is going to be the dimension style manager dialog box, modify, primary units, and down in the bottom right are angular dimensions. You're going to change from no decimal places to 4 decimal places. And then OK. And then set current and close. And then that's when you measure this angle and then you rotate copy the other 2 parts. Okay. Now, this question, they wanted us to determine the resulting displacement of the lower handle. Because that lower handle pivots around the fixed center of D, its angular displacement is that 34.3633 degrees, okay? So you need that dimension in place as part of your screenshot, okay? And then you also need the 15 degrees over here, and then the labels that we see here. You do not need to put the labels for the link any more than 1 time based on their home position, but you do need any points that moved. So X prime, B prime, C prime, Y prime, but D and A remained in the same place, okay? So those don't get a prime, all right? Now, there is one thing I forgot to do. I don't want you to forget it, and you need to do it, but you need to calculate the mobility, okay? It will be 1, okay? Because if we hold the snips as the top handle and we just move the bottom handle, there's only one thing we have to do to make that open. So your final answer for your F is going to be 1. Make sure you add that calculation either on the AutoCAD file here, or when you take your screen snips, I'll do that now. Okay, put it around here. I'm going to go back to my Word document and I'm going to say, okay, example 4.2. I'm going to put my screen snip. And then after it, you could add the mobility equation. So add mobility calculation. Okay, I didn't do it here, but I trust that you know how to do that. Now, something I've noticed when people are handing some things in, all right? So a couple of things, if I can have your attention for just a minute. On your problems, when you're handing in, you know how you're putting like example 4.1 and you put the thing right below. Sometimes people are doing the example 4.2 and then the illustration is a little large and it goes to the next page. Do one of 2 things. Either make the illustration smaller so it fits in that spot, or move the example 4.2 to the next page. Does that make sense? All right. I don't know why. It's like nails on the chalkboard to me. Like, okay, look at your files and label the things. Okay. So just paid little attention to that. I didn't take any points off for it, but those are the little, you're going to hand this to your boss, right? You want it to look nice. You want it to look nice. Like you looked it over before you gave it to that person. Okay. So at this point this evening, this is as far as I'm going to go on examples. So make sure that you do a file save as, and you're going to call this mod 2 practice, practice problems, right? Okay. And you want to be sure that you can recall it then, okay, the next time that we're together. Okay, because then you're going to add the next 3 practice problems to the same document because we've got the first 2 done. We didn't get them all done. All right. Now, before I let you go, you do have what you need, the skills that you need and the knowledge you need to do the first 6 problems in the assignment. Okay. So what I'm going to do is we're going to go over to our module 2, assignment 2, and I'll show you what you can get started on. So a couple of things in chapter 4 here, these are at the end of the chapter problems. It's going to be the first 6 problems that you'll be able to do, okay, based on what we did this evening. Now, you'll notice that you have the final answers for each one of these problems in a PDF down here. Before you hand in, make sure you get these answers, okay? If you don't, then you probably didn't set up something quite right, okay? You should be getting the exact answers that are here, especially when we're doing it in AutoCAD, okay? Now, let's take a peek at each one of these problems, okay? So these are going to be found, it's on page 101 at the end of our chapter. Yeah, starting on page 101, okay, right here. The first two problems that we have are 4.5 and 4.6. 4.5, it says graphically position the links of the compressor linkage in the configuration shown right here, down below. So you're going to draw it as you see it right here. It has all the dimensions that you need. Okay, the piston is a slider. It's going to go back and forth horizontally. It's in line with the what we'll call the frame or the fixed position here. And then our crank is going to be the short link right there. All right. Now, once you have this in place, you have all your labels, you have all of your links and your joints identified, you're going to do a mobility equation. Mobility equation is, or calculation is required for every one of these problems, okay? In this case, there is only one thing that you're going to move, and that's going to be this crank to get this to go back and forth. So your F should be equal to 1 when you're done, okay? You do that for everyone. It doesn't ask for it, but you need to do it in each one of your problems, okay? Then once you do that, you're going to reposition the 45 millimeter crank. So this is the crank right here, okay? You're going to reposition that so that it goes in a counterclockwise direction, 90 degrees, okay? So if I'm going to do that, if I'm going to rotate this back in a counterclockwise direction, 90 degrees, chances are my piston is going to move to the left along that horizontal line, okay? They want you to determine the resulting displacement of the piston. Since the piston is a slider, it's a linear displacement from the original position to the new position, okay? And then that is going to be the dimension that you add. You're going to compare it back to the answer key that we have. Should have kept that open, okay? And you should get a value of 66.8 millimeters to the left. Okay. All right. So that's your first problem. Now, when we look at number 4.6, number 4.6 says graphically position the links of the compressor. Well, there it is. You already drew the home position in 4.5. So you don't have to redraw it. You're just going to copy it for this next problem. Okay. But this time you're going to move your crank 120 degrees clockwise. So in the opposite direction, you're going to move it this way, 120 degrees from the 30 degrees. So it's not going to be from the 90 from 4.5. It's going to be from the 30, the home position. Okay. And then you're going to, again, determine the resulting displacement of that piston. Okay. So technically, these two, I use that same diagram. Okay. So by design, I did that. Now, for the next two, you're going to see that very same thing kind of play out. In this case, we have this shearing mechanism, okay? You're going to position the way you see it right here, and then you're going to reposition the link, the 0.75 crank. You're going to rotate it from where it's at right here, clockwise 100 degrees, okay? And then you're going to find out, okay, from that original position, how far did that linearly displace on that blade, okay? 4.8, same original home position, but this problem is a little different. It wants you to reposition the blade to be lowered 0.2 inches. So you're going to go from this position here down 0.2, and then you want to determine the resulting angular displacement of that crank. Okay. So it's kind of like going backwards. And then the last two, so the first 6 problems basically, are using this rock crushing mechanism. Home position for both 14 and 13. And then you're going to move it respectively for each one and then find the resulting displacement that it's asking for. Okay. So with what we did tonight, you can get, a chunk of our homework done. Okay. So, So that is where I'm going to leave you this evening as far as with new information. Okay, so the rest of the night this evening is going to be working independently on whatever you need to. Don't run off just yet, but I'm going to stop our recording here.